Okay, in this video, I'm going to solve every quadratic equation ever, and at the end of it, we'll be able to have a formula to help us solve quadratic equations. So I have the most general way we can think about it, ax squared plus bx plus c, where a, b, and c are all thought to be real numbers. Okay, these are just real numbers. We assume that a is not 0. A is not 0. If it was, then we wouldn't have a quadratic equation, and we would just use linear tactics to solve this. So it's not 0. Anyway, so let's solve all of them. I'm going to use completing the square. That's the strongest tool we have so far. So the first step to do that is to divide by that leading coefficient there. So we have x squared plus b over a plus c over a equals 0. Okay. Oh, and I should put an x there. Now, I'm going to make a perfect square, okay? Just like we did in completing the square, I'm going to make a perfect square. And I need to take that middle term there, and so that's b over ax, and I need to make that term that will make this a perfect square, so I have to divide by 2, and then I have to square it. I still have c over a equals 0. Oh, it no longer equals 0. It equals b over 2a squared now. I have to add it to both sides. Now, this is a perfect square. Okay, so I can, simplify that or factor it. So that would be x plus b over 2a squared plus c over a equals b over 2a squared. Okay, now I'm going to move the c over a to the right-hand side, and then we can start taking the square roots of things. So I have x plus b over 2a quantity squared equals, and I'm going to go ahead and square this. So that's b squared over 4a squared minus c over a. So again, I moved that c over a to the right-hand side, and I went ahead and squared this. All right, now I'm going to start combining things and doing the best I can of putting things together on the right-hand side before I take that square root. All right, well, the LCD here is going to be 4a squared. So I need to make this a 4a squared, and I need to multiply that by a 4 and an a to make that happen. So that's going to be c 4a to make that 4a squared. All right, now they're over the same denominator, so I can go b squared minus 4ac, might as well put them in alphabetical order there, over 4a squared. All right, I think I've combined them just about the best I possibly can. So I'm going to bring this back down. We'll just say that that was kind of a ditto. That's what we said in my classes back in the day. So now we're finally ready to start taking the square root, and that's what I'm going to do in this step. So I take the square root of both sides, plus b over 2a squared equals plus or minus the square root of b squared minus 4ac over 4a squared. Now I notice that that denominator itself is a perfect square, and so by the quotient rule of square roots, I can take the square root of that. Now the left-hand side is no longer squared, so I have plus or minus square root b squared minus 4ac over, it looks like 2a is going to fit there. Now I'm going to move the ba to the right-hand side. It's going to switch signs by doing that. I'll put it implied there. So this becomes x equals negative b over 2a plus or minus root b squared minus 4ac over 2a. Now, that's the answer. Generally, algebra textbooks will write this as negative b plus or minus root b squared minus 4ac, and then they'll put over the 2a. Okay, so that is the quadratic formula. Okay, this is the quad formula. Okay, now you can plug any question that you might have, quadratic equation, I should say. You can plug any quadratic equation into this formula and it will just solve for x. Let's look at an example and see how that might work. Oh, I don't know. Let's do 4x squared plus 2x plus 3 equals 0. It's kind of dangerous. I'm making one up the top of my head, but I just want to show you how we can plug it in. So by using the formula x, so again, this is A, this is B, this is C. So by the formula, x equals -2 plus or minus root 2 squared minus 4 times 4, because that's an A, times 3, C, and 2 times the A, which is 4. Okay, now the only thing we have standing in our way is arithmetic. So we have -2 plus or minus root 4 minus, and that's going to be 12 times 4, which is 48 over 8. Okay, and see, this is a good example because we're going to see that we're going to have a complex answer. We're going to have an imaginary answer here. So this was not factorable. This is still over 8. We have 4 minus 48, so that's 44. Okay, and I mean, we've essentially solved it, but I'm just going to keep going and simplify the best I can. 2 plus or minus. Now I can break out -44 as -1 times 4 times 11 over 8. Keep going down. Now I can take the 4 out of the square root, -2 plus or minus. If you take the 4 out, it becomes a 2. Have to leave the 11 behind. And from previous lectures, we have found that you can take the -1 out, and that becomes an I. Still have an 8 down here. And it looks like I can now finally simplify. So I have a 2 here, and an 8 here. So that becomes a 1, 1, and that becomes a 4. So x equals -1 plus or minus root 11i over 4. And there's our two answers. So I can use that quadratic formula because I've already completed the square for every single quadratic equation that ever will exist. So you can use this formula here. Again, that's x equals -b plus or minus root b squared minus 4ac over 2a. You probably saw that in high school. I think when I learned this, they just gave us the quadratic formula and they said plug it in and you will get your answer. But that explains where it comes from. It comes from completing the square generally, and you get that result. And now you can use this formula to solve any of your quadratic equations. So I'll have these notes posted so you can go over that again, but you don't have to derive this formula ever again. We can consider it done because I've already derived it, and so you can just start with the formula if you like. All right, so I hope that helps, and please reach out if you have any further questions.